Welcome, my dear students, to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 3, Normal Distribution, brought to you by Vitan Sir. Previously, we completed illustrations up to 12 number. Now, we are going to move forward with illustration 13 and so on. The bill amount of purchase by the customers in departmental store follows normal distribution with mean rupees 800 and standard deviation rupees 200. On a single day, 57 customers has bill amount more than rupees 1200. We have to estimate the total number of customers who visited store on that particular day. So we have the value of mean and standard deviations. We also know that 57 customers had bill amount more than rupees 1200. The first step we need to do here is write down the values of mean and standard deviations. Because we know that 57 customers had bill amount more than 1200, we will start by calculating the probability of X, which is equal to or more than 1200 rupees. So 1200 is less than equal to X, or X is more than equal to 1200. And when we convert it into Z, we get 1200 minus 800 upon 200 less than equal to Z. And the answer here is Z is greater than equal to 2, or 2 is less than equal to Z. So first of all, we will draw our curve. We know 2 is a positive value, so it will be on the right part of the curve somewhere here. And Z is more than 2. So more than values are on the right hand side. So on the right hand side of the 2 up to positive infinity, we are going to highlight the curve. So this is the actual value which we are going to calculate the probability for. Okay. So probability where Z is between 2 and infinity, we can't calculate it directly. So we will calculate it as 0 to infinity minus 2, 0 to 2. So the whole probability minus this probability will get us the answer of this. Now infinity is 0.5 and 2 is 0.4772 from the table value. We have already calculated these values beforehand in my previous tutorial, so this time I'm not going to show you the table for that. So 0.5 minus 0.4772 will get you the probability. Now the total number of customers which we are going to calculate it for, that is the number of customers, that would be 57 is equal to total customers. The probability is 0.0228. So to calculate the number of customers, we multiply total customers with the probabilities. So total customers would be, we will divide 0.0228 to 57. So 57 divided by 0.0228 is 2500. Okay. So to calculate number of customers, we multiply probability with total customers. We don't know total customers, but we already know the answer. So we divide answer with the probability to get the total customers, that is 2500. So on that particular day, the total number of customers visiting were 2500, out of which 57 customers had their bill amounts more than 1200 rupees. This is how we explain this situation. Now, illustration 14. For a group of 1000 persons, the persons are already given. The average height is 165 centimeters and variance is 100 centimeters square. This distribution follows normal distribution. From this, determine the third quartile and 60th percentile. Sorry, third decile and 60th percentile. We are supposed to calculate using this distribution. Now we know that total number of people are 1000, the mu is 165, the sigma square is 100, but we don't need sigma square, so sigma is 10. So let's start with the first one. According to definition of the decile, the third decile means that the 30% observations are less than the third decile. So we are talking about X less than 30% observations, and that D3 will be greater than the X, and the answer is 30%. So 30% observations are less than D3. So X less than equal to D3 is 30%. Now let's we have got our equation here, so let's convert it into a z value. So z is less than equal to d3 minus 165 upon 10 is equal to 30 upon 100. It is a pretty standard question here. D3 minus 165 upon 10 will be converted into z1. So z is less than equal to z1, that is 0.3. Now again we have to start drawing our curve here. Now, I have explained this before, but let me explain it again. That z is less than z1. So whenever less than sign is there, we start with negative infinity. If z is more than, we start with positive infinity. Right now 30% observations are less than the 3, so z is less than z1. Less than is starting from negative infinity. The probability is 0.3. So starting from negative infinity, we have to go towards the right side, covering 0.3 portion. Now this whole portion from negative infinity to 0 is 0.5, which is greater than 0.3. So we are not going to take this whole portion, we will stop somewhere here. So that would be your Z1, and this highlighted portion is your area. So when you convert this portion into our split ups equation, it will be negative infinity to 0 and z1 to 0, the difference. The answer is 0.3. Okay, we already have the answer here. Now negative infinity, we already know it is 0.5. So 0.5 minus 0.3. Okay, am changing the sides here, will be 0.2, which is z1 less than z less than 0. So this area here is 0.2, and from my table I have to find this 0.2. So let's start here somewhere 1915, 1950, 1985, 2019. So 0.2 is between these two values. Okay, so first value is 0.52 and 0.53. So this is a negative value, so we need to take an average of these two values. So negative 0.52 minus 0.53 upon 2 is negative 0.525. That is the z1 value. But what is z1? Z1 is d3 minus 165 upon 10. So we will put that there, which is negative 0.525. Multiply negative 0.525 with 10, you get d3 minus 165 is equal to negative 5.25. And then this negative 165 will be changed to the opposite side, that would be plus 165, and your answer of D3 will be 159.75. So your answer for D3 is 159.75 centimeters. So the third decile is 159.75 centimeters. Let's move on with 60th percentile. Once again, according to definition, P60, that is 60th percentile, means that 60% observations are less than P60. So when we think about that, again we have to write with the equation that x is less than P60 is 60%. Converting this into the z-score is P60 minus 165 upon 10. We will write down this as again z1. If you want, you can write it as z2, but I am just continuing with the z1 value here. So that would be 0.6. Once again, I have to start by drawing my curve. Now z is less than z1, that is 0.6. Whenever it is less than, z value is less, we start with negative infinity, and it is 0.6. So naturally, if I am going to start with negative infinity and count back up to 0.6, it is going to change the sides, because this part is 0.5 and 0.6 is greater than that. So 0.6 will end somewhere here. So that would be the z1 point. So this is the whole area which I am going to highlight for showing the area 0.6. So it is negative infinity to 0 and 0 to z1, and the total is 0.6. Now infinity is 0.5, so that 0.5 I am totally going to subtract from 0.6 here, changing the side. 0.6 minus 0.5 is 0.1. So right now this area is 0.1, and I need to check the table inversely. For that purpose, I have to find 0.1 here, just 0.1. So starting here it is 0 0, it is more than 0.1. So horizontally checking out, okay, this is 0.09 and this is 0.1. So somewhere between these two values lies my area 0.1. So 0.25 and 0.26, and that these values will be positive values. So 0.25 plus 0.26 upon 2 is 0.255, which are positive values. Now here Z1 is actually P60 minus 165 upon 10, so I will write that down. uh, 10 will be taken on the opposite side to multiply, so that would be 2.55, and then I will add 165 in there. So my answer here will be 2.55 plus 165 is equal to 167.55. So the value of 60th percentile in this distribution is 167.55. I hope you guys are getting this properly. So the third decile and the 60th percentile, actually you can calculate any value you want, not just the decile or percentile, but you can even calculate quartile if you want. You just need to remember that the values of quartile are 25, 50, 75. Deciles are 10, 20, 30, 40, 60, 70, 80, 90, and percentile ranges from 1 to 99, any value in that. So according to question, you can find your answers using these deciles, percentiles, and even quartiles. But usually for quartiles, you have the direct formula, that is Q1 is 0.675, and Q3 is Q1 is negative 0.675. That is from the table you have to find that value, and Q3 is positive 0.675, which you can find the probability of from table. Okay, moving on. Illustration 15. A manufacturing company produces electric bulbs, and life of electric bulbs follows normal distribution. Its average life is 2040 hours. If 3.36% bulbs have life more than 2150 hours, then find the variance of the life of bulbs. Okay. Now in this question, as you can see, mean is given, percentage and the value of x is given, but the variance is not given. So what we are going to do here, we are going to say that the life of bulbs which are greater than 2150 hours is 3.36%. Okay, so 2150 is less than equal to x, that is 3.36%. That is x is greater than 2150, the chance are 3.36%. Converting this into a z-score value, 2150 minus 2040, because we have the mean but we don't have the standard deviation, so I'm just going to write sigma here in place of any value, which is 3.36 upon 100, that is converting the percentage value into a probability. So 2150 minus 2040 is 110 upon sigma less than equal to z. I'm going to convert this portion 110 upon sigma into Z1. So Z1 less than equal to Z is 0.0336. Once again, Z is greater than Z1 here. I have to start by drawing up a curve. Now, as you can see, it is greater, and greater value means we start from positive infinity. And as you can see, the probability value is very, very small. So we will only highlight this small area starting from positive infinity. And because we are highlighting very small area here, Z1 is almost on the extreme left side, right side of the curve here. So this is Z1. This is the area which we have right now. So this will be our equation, that is probability of 0 to infinity and minus probability of 0 to Z1, which is 0.0336. Infinity is 0.5, Z1 we don't know. So the difference we are going to directly calculate as 0.5 minus 0.0336, that is 0.4664. We will take out the table right now. Now Z1 0.4664, we will try to find it here. 0 0 1 1 2 2 2 3 3 3 4 4 4 4 4 4 6 4 6 4 1 4 6 4 9 4 6 5 6 4 6 6 4. Exact value is available. So 4664 is 1.83, and because it is in the positive side, Z1 is 1.83, but in the place of Z1 we are naturally going to put 110 upon sigma right now. So 110 upon sigma is 1.83. Now I am going to swap the sides. 110 upon sigma, sigma will be taken on the opposite side, and 1.83 will be taken in the place of sigma. So it will become 110 upon 1.83 is equal to sigma. The answer naturally is 60.11 is equal to sigma. But we don't need sigma. The question is about variance. Variance is the square of sigma. So sigma square will be 3613.21. So my dear students, this is your answer. The variance for the distribution is 3613.21. We will move on with the next illustration. Illustration 16. The profit in daily business of a businessman having grocery shop follows normal distribution. Variance of profit is 22,500. Okay, so variance is given and the probability that daily profit is less than 1000 is 0.0918. So profit less than 1000 has probability, so that is also given. So naturally what we are left with is to calculate the average daily profit. So this is the opposite question of the last one. Here variance is given and profit, average profit is to be calculated. Now the question given here is that profit less than 1000. So x less than 1000 is 0.0918. Here mu is not given, sigma square is 22,500, but we don't use sigma square, we just use sigma. So 22,500 root will be 150. We will put this into equation. X is less than equal to 1000, 0.0918. Converting this into our standard Z format, 1000 minus mu, because average is not there, so just mu upon 150 is 0.0918. Again I am going to assume this as Z1 value. So Z less than Z1 is 0.0918. Now this time it is a less than value. Because this is a less than value, we start with our negative infinity corner. So first we will draw the curve. Now because we are starting with the negative infinity corner and the probability is very small, I am only going to highlight this much portion of the curve. Okay, so starting from negative infinity, a very small portion is highlighted. So right now my split up will be negative infinity to 0 and minus z1 to 0. The probability is 0.0918. I already have this negative infinity value 0.5 here. So 0.5 minus 0.0918 will be 0.4082. So this is the area which is 0.4082, and from that I can calculate the value of Z1 using my inverse table. So I have to find 4082 here. This is 340404082 is directly there, which is 1.33, but this is a negative value, so my Z1 value here will be negative 1.33. Now Z1 is 1000 minus mu upon 150, so that would be equal to negative 1.33. 150 will be multiplied with negative 1.33, so 1000 minus mu will be negative 199.5. Now I am swapping the sides here. Mu will be on the right hand side being positive and negative 199.5 will be on the left hand side being positive once again. So 1000 plus 199.5 is equal to mu. Therefore mu is rupees 1199.5. So the average daily profit is 1199.5 rupees. My dear students, in the textbook, in the illustration itself, they have made some calculation errors. So the answer given in the textbook is 800.5, which is a completely wrong answer. It is not possible actually. Okay, so this is the correct answer which you are supposed to calculate. You can see here that from following the calculations we get the same answer. If you want to compare, you can compare textbook with this. Moving on towards the last illustration of this tutorial. Illustration 17. The maximum temperature of a city in summer follows normal distribution. On a particular day, the probability that maximum temperature will be more than 31 degrees Celsius is 0.3085. Okay, one probability is there. Whereas it will be less than 27 degrees Celsius is 0.0668. Okay, they have already provided with two probabilities, but no mean and no standard deviation is there. That means using these two separate set of probabilities, we have to find the values of mean and standard deviation. Okay, now this is one of the most classic sums of this chapter, asked many times in 4 marks, but because it uses the inverse table, it might not be asked in this board exams because due to this COVID-19 situation, it has been cancelled. Still, I'm going to add this into a video because in the future it will be helpful to you guys. So let's start. The first probability given here is that more than 31 degrees Celsius. Okay, so x greater than 31 is 0.3085. So x greater than 31 is 0.3085. We will start by converting this into z-score. Because we don't have the values of mu and sigma, I am just going to write mu sigma here in the place of any value, and then I will be converting this value into z1. So I will just assume that 31 minus mu upon sigma is z1. So z1 less than z is 0.3085. Now z has a greater pole value. So whenever z is greater than type, we start from the positive infinity. Now, starting from positive infinity, we have probability 0.3085. The whole part is 0.5. So this is a smaller value than that. So it will end somewhere here. So Z1 will be there, and the more than value, the more than portion here will be highlighted for that purpose. Next, we have to show a split up from 0 to infinity, and minus 0 to z1. The probability is 0.3085. Now 0 to infinity is 0.5. So naturally 0 to z1 is equal to 0.5 minus 0.3085, which is 0.1915. We will check this out into our inverse table. 1915, 11111915. Okay, it's so easy. It is directly here in 0.50. So because z1 is a positive value, it will be positive 0.5. Now z1 is 31 minus mu upon sigma. So I will just write it down as it is. Change the side of sigma, so it will be 31 minus mu is equal to 0.5 sigma, and mu will be taken as positive. So 31 is equal to 0.5 sigma plus mu. Now I am going to keep this as it is because I don't have any mu or sigma values. Okay, so I will just consider it as my first equation. Yes, my dear students, we are going to prepare two equations. From first probability, we have got our first equation. Now we will be using the second probability to get a second equation, and then we will use the elimination method for the purpose of finding mu and sigma. So let's start with the second equation here. In the second equation, it was written that temperature less than 27 degrees Celsius. So x is less than 27. The probability was 0.0668. Naturally, we are going to convert it. Mu and sigma will be as written as symbols. Values are not available yet. And this time I'm going to depict it as z2 rather than using the z1 value. Z1 we have already used, so this time I'm going to use it as z2. So z is less than z2, which is 0.0668. So when I draw a curve, it is a less than type. Less than starts from negative infinity, and as you can see, the probability is very small. Okay, it is very small, so it will be only here. If the probability is more than 0.5, then only the sides are changed. This is a small probability, so it is going to be depicted here somewhere, which is z2, and this is the portion which will be highlighted. So we are going to use this and draw a split up of negative infinity to 0 minus z2 to 0, that is 0.0668. So z2 less than 0 is 0.5 minus 0.0668, that is 0.4332. Once again, we have to check the inverse table here. 4332, it is directly here. 1.50, 1.50 is that. So the z2 value is negative 1.5. Why negative? Because z2 is on the left hand side of the curve, so it's a negative value. So z2 is equal to negative 1.5, and we will take the z2 value is 27 minus mu upon sigma is negative 1.5. So when we change the size, it becomes 27 is equal to negative 1.5 sigma plus mu. This is our second equation. Now we are going to eliminate. So we will be subtracting the second equation, second equation from the first equation. Okay, so for that purpose, I will write down the first equation as it is, and when I write the second equation, I will inverse its signs because I am subtracting it. So positive 27 will become negative 27, negative 1.5 sigma will become positive 1.5 sigma, and positive mu will become negative mu. So when I subtract it, 31 minus 27 will be 4. Both of them will be added, so this will become 2 sigma, and these mu's will be cancelled because they are positive and negative. So the answer which I will get is 4 is equal to 2 sigma. So naturally sigma will be 2. Now what I am going to do, I am going to put this sigma value 2 in this equation here. So 31 is equal to 0.5 bracket 2 plus mu. So 31 is equal to 1 plus mu. So when I change the side of 1, it becomes mu is equal to 31 minus 1, that is 30. So in this long question, mu is 30 and sigma is 2. So this is a 4 marks question in which there are 3 steps. First we calculate the first equation, then we calculate the second equation, and then we eliminate these equations to find the value of sigma. That's the third step. And then we put that value of sigma into any of the 2 equations. You can put it in the second equation also if you want. You will get the same answer. And by putting the value of sigma into any of the equations, you get the answer of mu. So mu is 30 and sigma is 2. And this is the last question of this tutorial, so I am ending it here. In my next tutorial, I will be completing all the remaining illustrations because small illustrations are left, no big illustrations are left anymore. So we will be discussing those illustrations and ending that chapter. I hope you guys are getting how this normal distribution works with the use of curve and the table. You need the curve and you need the table to calculate an accurate answer for this purpose. Thank you very much for watching this tutorial. Let me know your uh, experiences or feedbacks. Like this video, and if you are a new person, subscribe to my channel. Thank you very much. Welcome students to Vitan's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.